Okay, David, really quick. I'm making a quick little video here for you. So the point of the back page here is to take a look at, does it take a lot of water to light a light bulb? So we're looking at hydroelectricity. And then it says that depends on the wattage and how long it glows. So in the calculations below, you're going to calculate the mass and the volume of water that falls over a 10-meter high dam to keep a 100-watt light bulb glowing for 1 year. So the calculations are all kind of set up for you here. So the first calculation, we're going to calculate energy in joules required to keep the bulb lit for 1 year. So they have it all laid out because energy is power times time, like what we talked about in the electricity unit. And we know that we have the 100 watts times the 1 year. Then each of these calculations is doing the conversion for you here to be able to get it to joules. So this is basically saying that this is like 100 over 1 and 1 over 1. So you're going to take 100 times 1 times 1 times 365 times 24 times 3,600. So when you do that, you get a really big number, which is easier to write in scientific notation. So you get 3.2, if I round this to 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th joules. So the math is all really laid out for you. And that's what they're trying to help you with here, so you don't have to do all the math from scratch. So when you do the math here, you get 3.2 times 10 to the 9th joules. So then this number comes down here. So what mass of water elevated 10 meters has this much potential energy? So we haven't covered potential energy as far as gravitational potential energy yet, so this kind of lays it out for you though, and then solves this equation. This solves this equation for mass. So mass equals the potential energy, which is what you calculated here. So this number is going to come down here. So this is going to be 3.2 times 10 to the 9th joules. And then you're going to take this number divided by those two numbers multiplied together. You got to follow your order of operations. So this is 9.8 times 10. So you got to do that first and then do the division. And you'll get your answer of your mass in kilograms, which should be about 3.3 times 10 to the 7th kilograms. Then you're going to take this answer, and that's going to come down here, and you're going to do the math there. You're going to take that times that, which is going to give you your mass in kilograms, because the hydroelectric plant is only about 20% efficient. That means that we have to burn 5 times as much in order to get up to 100% efficiency of this energy rating. Then when you get this number is going to come here, and then you're going to figure out the volume, and then you want to compare that to how many poolfuls, thinking that might be something that you might be familiar with. So then when you calculate the volume, then you'll take that number, and that number will go here, and that will give you the number of poolfuls. So that's what we're looking for, and that's why they have the calculations laid out the way they do. Sorry for my voice, but that's why I'm not there today.